In this video, we will discuss further more about shear force and bending moment. So, this is a beam, very small element with length dx, and for very small length, we can consider load is uniform. Now, moment m is acting, and after dx length, there is a m plus dm, and here shear force in upward direction on this surface acting, which is v, and here v plus dv, opposite direction. Now, if we apply summation of Fy equal to 0, equilibrium equation on this, then upward V minus downward V plus dV will be equal to this load which is in downward direction W into length dx, because this is Newton per meter. So Newton per meter into meter, which is length dx, and from that we get dV by dx equal to minus W. So here slope of shear force diagram will be equal to this load. So here the load is constant, so slope of shear force diagram will also be constant. So from this we can conclude that slope of shear force diagram, if we take dv by dx, then that will be equal to negative times load. And if we take area of load diagram, so if we integrate both side, v equal to integration w dx, so this is area. So area on load diagram will be equal to shear force. So this is a very important result. Similarly, if we apply summation of moment at a point equal to 0, then moment m minus opposite moment m plus dm plus this is w times dx total load, and which we have to assume at center point, so dx divided by 2. So w dx, which is a load, total load, and it is acting at dx by 2, plus v plus dv into length dx, and this shear force is passing through point 8, so we do not have to consider that. From this, if we neglect dx 2 times dx square, which is very small, and dv dx, that will be also small, then we will left with this result, which is dm by dx equal to shear force. So from here we can conclude slope of bending moment diagram dm by dx, which will be equal to shear force. And if we integrate this, then we get m is equal to integration v dx. Integration v dx is area of shear force diagram. So area of shear force diagram is bending moment. So here if we take integration of both side, we get m equal to integration v dx, that will be equal to area of shear force diagram v into dx. So that will be equal to moment. So these two result we have to remember, and these 4 points we have to use it in our case of numericals. So these are some cases which I have derived from both these equation. First case is when there is a point load. So you see here two supports and one point load is there. So if there is a point load, that means shear force will be constant. Here each and every point shear force will be constant. So on this side it will be positive, on other side it will be negative, but it will be constant because the load is acting here as a point load. And if we integrate it, we get this constant, the dv by dx is equal to w. So here load is constant, point load is there, so slope should be 0 because there is a no load on this region, so slope should be 0. Similarly here shear force is constant, and if we integrate this area, then we get bending moment at this point. And if you see this is shear force is constant, so if this is constant, then dm by dx, which is a slope should be constant. So this is a constant linear slope, shear force value is constant, so here slope should be constant. Similarly for second case, if w is constant, then if w is constant uniform, then slope is constant. So here slope is constant for shear force. Here w is negative, that's why negative slope, so this is a negative slope for shear force. Here wherever there was a positive shear force, area is positive, so positive slope. here it is negative, so afterwards from center point it is negative. Similarly here w is negative, slope is negative for shear force, and w is constant, so slope is constant. Now on this side it is positive, on this side it is negative, so here positive but value is decreasing, so shear force value is decreasing, means moment diagram slope value is decreasing. So slope is here, it initially it is this slope, afterward it is getting slightly reduced, and at final at this point the slope is 0. So slope value is constantly reducing because the value of shear force is decreasing, so slope value should decrease, and it is in positive direction, so all positive slopes. On this side slope value is increasing, so from 0 to maximum value, like this. So slope value is increasing, and uh, this slope value is increasing, and it is a negative side, so all the slopes after center point, all the slopes are negative. So anywhere slope on this side is positive, on other side from the center point is negative. Here slope is decreasing, here increasing, because the value of shear force is decreasing and then increasing. The third case is when w is linear. So this linear shape is there where it is constantly increasing. So if this is linear, shear force should be parabolic, because shear force is integration of this, so integration of linear is parabolic. So this is parabolic, and it is having a negative slope because the w is in negative direction. And and if you see this curve, it is parabolic because it is constant, and slope value should increase because w value is increasing, though it's in negative direction but it is increasing. So here slope is this much, here slope is this, so from this to this it is increasing continuously. So slope increases because the w value is increasing in negative direction, so negative slopes, all the slopes are negative. And from here this curve is parabolic, so bending moment curve should be cubic. And if you see, the shear force value is decreasing till this point it is decreasing and then increasing, and shear force here positive, here negative, so on this region it is positive, so all the slope will be positive because shear force is a slope of bending moment. So bending moment slope and shear force should be same, so shear force is positive, so slope should be positive, so here slope is positive, and the value of shear force is decreasing, so slope value should decrease. So you see here this higher slope, at this point it is lower slope. Now after this point the value is increasing, so slope value should increase. So here if you see after this point, from zero slope, the slope values are increasing, and it is in negative direction below zero line, so all the slopes after that point is in negative direction, from positive, positive to negative slopes. So these are some basic concepts. We will discuss many concepts regarding shear force and bending moment in future videos. Thank you for watching this video.